Like I said, this is the last section of chapter 2, 2.6, solving absolute value inequalities. Sorry, it's kind of hard to read. I didn't realize the blue background would not show up very well on my screen. But I think it gets a little better later on throughout the slides. So, we've solved absolute value equations before, correct?
Correct. Very correct.
We've seen equations like that before? Anyone remember how we would solve that?
Minus 21 on both sides.
Say what?
Subtract 21 on both sides.
21.
2.
That's the absolute value of x plus 2. Ryan?
You get two equations.
Very good. Before I get my two equations, though, I got to make sure my absolute value is by itself. And I got to make sure my c value is greater than or equal to 0 in order to make the two equations. It has to fit both those conditions to make my two equations. So is the absolute value by itself here?
No. Yes.
Yes, it is. Is my c value greater than or equal to 0 or less than 0?
Greater than.
Greater than or equal to. So I can set up my two equations. You guys remember what my first equation is?
X plus 2 equals 3.
Very good. Exactly the same without the bars. What would my second equation look like?
X plus 2 equals negative 3.
Very good. Exactly the same. I'm just accounting for that negative value now. And then I would solve both equations, right? Subtract 2, subtract 2. Subtract 2, subtract 2. I'd get x equals 1. X equals negative 5. You guys somewhat remember that from last chapter. Today is similar to this. There are some differences, but keep this in mind whenever we're doing it. We are going to come up with two inequalities instead of two equations. Okay? So let's get into it. Solving absolute value inequalities. So, this first part is for absolute value inequalities that are less than or equal to. Okay? So, to solve, the absolute value of ax plus b is less than c, or less than or equal to c, for c is greater than 0. Remember, for our equations, this was c is greater than or equal to 0, right? For inequalities, it's just c is greater than 0. So make sure your c value is greater than 0. So to solve that, we solved the compound inequality. We talked about compound inequalities yesterday, right? Two inequalities put together with the word and or between them. So in order to solve that, I solved the compound inequality. Ax plus b is greater than negative c, and ax plus b is less than c. If you notice, one of my inequalities is exactly the same as my original without the bars. Just like with equations, right? So, you can always get your first equation by dropping the absolute value bars. It's exactly the same, just without the bars. Correct? I want to see that. My second equation. Once again, I make my c value negative for my second equation. Now that we're dealing with the inequalities, though, I also have to flip my inequality symbol for my second equation. Everyone good with that? So first one, exactly the same without the bars. Second one, make your c value negative, flip your inequality symbol. There's your two inequalities. Questions there?
Nope.
Anytime it is less than or equal to start off with, it's going to be an and compound inequality. Did someone have a question?
Why do we make the other one negative again?
Because when we're dealing with absolute values, we have to account for our positive value as well as our negative value. Okay? So are there any questions about that first set of absolute value inequalities? Okay. The second part is for absolute value inequalities that are greater than or equal to. Okay? So to solve, absolute value of ax plus b is greater than c, or is greater than or equal to c. Once again, for c is greater than 0. Solve the following compound inequality. Once again, one of my inequalities is the exact same as the original without the bars. The exact same. once again, for the second inequality, make the C value negative, flip the inequality symbol. Okay? First inequality is always the same, without the bars. Second one, make your C value negative, flip the inequality symbol. Anytime it starts off as greater than or equal to, it's going to be an or compound inequality. Okay? That's going to be kind of hard to remember, isn't it? To decide if it's and or. Because for specific ones it's and, for specific ones it's or. That's going to be kind of difficult, isn't it? Lucky for you guys, I've got hopefully a little trick that'll help you remember if it's and or. Okay? So after I write this, I want you to write it on your paper as well. It's the word goal. Everyone see how that's the word goal? Okay. With my G, there's a greater than symbol, correct? And my L is a less than symbol. So this greater than symbol is next to my O. What do you think the O stands for? Not 0. Or the less than symbol is next to the A. What do you think the A stands for? And. So, if my original inequality starts off as greater than, right here, it's next to the O, so I know it's going to be an or compound inequality. Everyone see that? If my inequality starts off as less than, it's next to the A, so I know it's going to be an and compound inequality. So I would have goal written on my paper just like that. That way I know when to use and I know when to use or. Are there any questions before we move on to some examples? We okay? Okay. Okay, letter A. It says solve each inequality. Graph each solution if possible. So, is my absolute value by itself? Yes, it is. What's my C value in this case? 2. Is my C value greater than 0? Yes, it is. If it meets those two conditions, I can now set up my two inequalities. So what's my first inequality going to look like?
X plus 7 is greater than or equal to, or less than or equal to.
Very good. X plus 7 is less than or equal to 2. Exactly the same as my original, just without the absolute value bars. Everyone okay with that?
Yes.
Okay, what's my second inequality going to look like?
X plus 7 minus 2.
Very good. Some collaborative thinking here. Got a few answers from a few people when we got it together. It's the exact same. My C value is now negative, and I flip my inequality symbol. So X plus 7 is greater than or equal to negative 2. So everyone see how we got our two inequalities. You're going to follow that same format each time you're setting up your two inequalities. First one's exactly the same without the bars. Second one, change your C value to negative. Flip your inequality symbol. Okay? Is this going to be an and or an or compound inequality? What? And. My original starts off as less than, correct? So I find the less than symbol in the word goal. Is it next to the A or the O? A, so I know it's and. Everyone see how we used goal to figure out if it's and or. Not too bad? Okay, now I can just solve my compound inequality. So what's my one step on both of these to get X by itself?
Subtract 7.
Subtract 7 from both sides. Subtract 7 from both sides. 2 minus 7. What? Negative 5. Very good, everyone. Good job. Does my symbol flip or stay the same? Stays the same. I did not multiply or divide both sides by a negative, did I? So it stays the same. Bring and down. Now this is just like yesterday. I'm solving my compound inequality. Negative 2 minus 7. Negative 9. Symbol flip or stay? Stays the same. Are both inequalities, do they both have the variable by themselves?
Yes.
Yes, so here would be my solution. What would be another way to write this? Anyone remember the special way to write an and compound inequality?
Yeah.
So just x is less than or greater. Wait, never mind.
Would be negative 5 is less than, no, greater than x. Yeah?
I want my smaller number first, right?
Oh, alright. Well, so negative 9 is less than x. That is, what is less than negative 5?
Very good.
Yeah.
My smallest number goes on the left. My biggest number goes on the right. My variable goes in the middle. Between x and negative 5, what's the alligator eating? Negative 5. So I got to make sure the alligator's eating the negative 5 between x and negative 5. Between x and negative 9, what's the alligator eating? The x. So between negative 9 and x, I got to make sure the alligator's eating the x. If you do not like to write it like this, or you get confused writing it like this, don't do it. Leave it like this. I'm okay with that. Everyone got it? They mean the exact same thing. Okay, let's graph it. Open or close dot on negative 5? Closed. Open or close dot on negative 9? Closed. Okay, this is an and compound inequality. Am I looking for the union of my two graphs or the intersection? Intersection. So where my two graphs intersect, where they overlap, where the shading is the same. So, if x is less than or equal to negative 5, would that be shaded to the left or to the right of negative 5? To the left. For x is greater than or equal to negative 9, would that be to the left or to the right of negative 9? To the right. So where would the intersection be? The overlap of the two shaded areas?
Negative 9, negative 8, and 7.
Between my 2 points, right?
Yes.
Would it go past either point? No. Because my solutions have to meet both of my inequalities at the same time. They have to be less than or equal to negative 5, and at the same time, greater than or equal to negative 9. Okay? So that would be my graph. Any questions on letter A? Pretty decent. Kind of a long-ish, tedious process. But once you get the hang of it, it starts to go pretty quick. Okay? Can I erase and move to B?
Indeed, you may.
Okay, can someone help me out with letter B?
Well,
X.
as
Yes.
8x minus 11 is less than 0.
Okay.
8x minus 11. Probably. Never mind. Greater than. Have to make it 0.
Yeah, there's not a negative 0, is there? Oh. I guess would this be and or? And. Is everyone in agreement with this, or are there any disagreements?
It's just confusing me.
I disagree because there's no negative 0, so why would you switch it?
Well, we didn't switch it, did we? We just put it at 0.
Well, no, you changed the sign.
Oh, yeah, I see what you're saying. Okay, I disagree as well. Okay. Is my absolute value by itself? Yeah, it is. Yeah, it is. Right?
It is.
Is my C value greater than 0?
No.
No, it's not.
It's equal to 0.
It's equal to 0, but it's not greater than it, is it?
It has to be greater than 0?
It's got to be greater than 0.
Oh, okay.
Right?
Oh no.
For C is greater than 0.
Okay, I thought it was like greater than or equal to.
That's for our equations.
Yeah.
For our equations, it's got to be greater than or equal to 0. But we're dealing with inequalities now, right?
Yeah.
So for our inequalities, it's got to be greater than 0. So is my C value greater than 0 here?
No.
No, it's not. So if it's not greater than 0, I can't set up my two inequalities. Okay? So this is not correct. Good try, though. Good try. So now I've got to look at what the statement is saying. Absolute value of 8x minus 11 is less than 0. What values are less than 0?
Negatives.
Negatives. Can absolute values be negative?
No.
So this is essentially saying my absolute value is negative because it's saying it's less than 0. So what's my answer here? No solution. Does everyone see why it is no solution? Like I said, does everyone see why this one is no solution?
C.
Okay, let's talk about something real quick. What if this was the problem it gave me?
Still,
8x, absolute value of 8x minus 11 is greater than 0.
it won't matter because the C value is still less than 0.
Well, my C value is not greater than 0, is it?
No.
So let's look at the statement that it's saying. 8x minus 11 is greater than 0. What values are greater than 0?
Positive.
Positives.
And if the absolute value
The absolute value is greater than 0. It's different than the.
Wow.
It's. I believe it would be different than if you're writing an equation.
This will be different, yep. Can my absolute value be positive?
yes.
There's always going to be positive, or what? What's the only other thing it can be besides positive? 0, right? Does my inequality say greater than or equal to 0? No. So here's what I would have to do on this one. Usually this would be all real numbers, but it is not all real numbers because if I plug something in here, I could get 0 out of it, and that would give me a false statement because 0 is not greater than 0. So here's what I'd have to do. Set up one inequality and solve that one inequality. That's going to give me the value that would give me 0 in my absolute value. So I'd add 11. 8x is greater than 11. Divide by 8. X is greater than 11 over 8. So this would actually be my solution of this problem. Okay? Because if I plug in 11 over 8, that's going to give me 0 in here. What's the absolute value of 0? 0. And 0 is not greater than 0, is it? So I need all the values that are greater than that value that gives me 0. Does that make some sort of sense? So it's got to be greater than the number, the one number that gives me 0. So it's not all real numbers, it's just the values that are greater than 11 over 8. So, if your C value is not greater than 0, but it is 0, it's either going to be no solution, or you're going to have to solve to get the value that gives you 0. Okay? Now, if this said greater than or equal to 0, that would be all real numbers right there. Because no matter what I plug in, it's going to either give me a positive value or 0, and that's always going to be true. Does that make sense? Or are these words just going in one ear out the other? Hopefully not. Can I move on to my last 3 examples? Last 3. Number 4. Absolute value of x plus 3 is greater than 8. Is my absolute value by itself? Yes, it is. Is my C value greater than 0? Yes, it is. So can I just set up my two inequalities?
Yes.
Indeed, I can. Raise your hand if you can give me my first inequality. Yes.
X plus 3 is greater than 8.
Very good. X plus 3 is greater than 8. Exactly the same, just without the absolute value bars. Raise your hand if you can give me my second inequality.
X plus 3 is less than negative 8.
Very good. Exactly the same. My C value is now negative, and I flip the inequality symbol. Everyone okay with that? Raise your hand if you can tell me if it's going to be and or. An and or an or compound inequality. Yes. Is it going to be or? Yes, it is. My original starts off as greater than. So I find greater than on the word goal. It's next to the O, so I know it's going to be or. Questions how I've set this one up? Are we all getting better at it? Understanding it a little more.
Yeah.
What's my one step on both of these? Subtract 3 from both sides. 8 minus 3. 5. Symbol flip or stay? Stay. Negative 8 minus 3. Negative 11. Symbol flip or stay? Stay. There's my solution. Questions on how I got that? Open or close dot on 5?
Open.
Open. Open or close dot on negative 11?
Open.
Open. Am I moving too fast for anybody? Okay, this is an OR compound inequality. So am I wanting the union of my two graphs or the intersection?
The union.
The union of my two graphs, which just means I graph them on the same graph. Correct? So, x is greater than 5. Is that to the left or right of 5?
To the right.
To the right. X is less than negative 11. Is that to the left or right of negative 11? Left. There's my graph. I'm done with number 4. Any questions how I got it? Not too bad? Can I erase and move to 5? Absolute value of n plus 2 minus 3 is greater than or equal to negative 6. Is my absolute value by itself?
No.
Okay, how would I get it by itself?
Add 3 to both sides.
You got to get rid of that minus 3. Use your inverse operations. Add 3 to both sides. So I get the absolute value of n plus 2. Negative 6 plus 3 is? Negative 3. Does my inequality symbol flip or stay? Stays the same. Is my absolute value now by itself? Yes, it is. Is my C value greater than 0? No, it is not. So can I set up my two inequalities? No. Let's look at the statement that it's saying. Absolute value of n plus 2 is greater than or equal to negative 3. What's my answer here?
Get the solve like for 1.
Any number I plug into my absolute value is going to give me what?
All real numbers.
It's all real numbers. Because any number I plug in is going to give me what?
Positive.
A positive or 0. Is a positive or 0 always going to be greater than or equal to negative 3? Yes, always. Any number I plug in is going to give me a positive or 0. 0 and a positive will always be greater than or equal to negative 3. It won't be equal to, but it'll be greater than, so it still makes the inequality true. Does that make sense for number 5? Yes, no, maybe so.
Yes.
Good. Can I erase and move to 6? Last example for the day. 3 times the absolute value of d plus 1 minus 7 is greater than or equal to negative 1. Is my absolute value by itself? No. I want you guys to get in the habit of asking yourself that every single time when you're solving these. Is my absolute value by itself? No. Okay, I got to get it by itself. What would be my first step to get it by itself?
Distribute 3.
Add 7 to both sides. I cannot distribute through an absolute value. I've had some other people say that, but I cannot distribute through an absolute value. -1 plus 7. 6. Does my inequality symbol stay the same or flip? Stays the same. Everyone okay with that step? Is my absolute value now by itself?
Yeah. No.
It is not. It's got 3 times my absolute value. How would I get rid of that 3 times my absolute value? Divide by 3. Using your inverse operations. Inverse of multiplication is division. Six divided by 3? 2. Does my inequality symbol flip or stay? Stays the same. Is my absolute value now by itself? Yes, it is. Now I can finally check my C value. What's my C value now? 2. Is my C value greater than 0? Yes, it is. So can I set up my 2 inequalities? Yes, I can. What's my first one?
D plus 1 is greater.
D plus 1 is greater than or equal to 2. Exactly the same without the bars. What's my second inequality? Very good. Exactly the same. I make my C value negative, and I flip my inequality symbol. Now, looking at my inequality symbol over here, in my new original problem, is it greater than or less than?
Greater.
Greater than. So is it and or? It is or, because the greater than symbol is next to the greater than on the word goal. What's my one step here to solve these two? Subtract 1 from both sides. 2 minus 1? 1, symbol flip or stay? Stay. Bring down your or. -2 minus 1. -3. Symbol flip or stay? Stays the same. Here's my solution. Question's how I got it. And finally, let's graph it. Open or close dot on 1? Closed. Open or close dot on -3? This is or, so is it the union or intersection of the two graphs? Union. So I'm graphing them on the same graph. D is greater than or equal to 1. Is that to the left or right of 1? To the right. D is less than or equal to -3. To the left or right of -3? To the left. There'd be my graph of 6. Any questions on it? Any questions about any of the notes we just took? Can I move on to the assignment? All right. Here's our assignment. Page 95, numbers 2 through 18, evens. This will be due Monday, October 4th on Canvas. I think it's about 9 problems. It's not too bad. 2, 4, 6, 8, 10, 12, 14, 16, 18. 9 problems.
Hey, that's when Black Widow comes out. Plus,
There you go.
Hey, I'm gonna watch it.
There you go. Are there any other questions before I end my recording?